Hello again, and welcome back for some more statistics. So we're going to be jumping into chapter 2 now, and that gets into frequency distributions as well as other techniques for summarizing data. So 2.1, the first part of this gets into just the chapter objectives, so it kind of gives a ballpark overview of everything. So if we look at the last chapter, we looked at statistical thinking, methods for collecting and identifying data. Now we will look at organizing, summarizing, and representing in a convenient and meaningful form. The following are some important characteristics of data that we will be examining in this chapter. So center is a big one. Anytime you're dealing with numerical data, at least, you want to know where the center is because that kind of summarizes all of the data in general. So it's a representative or average value that indicates where the middle of the data set is located. So that's one important piece of it. Variation is also important. So it's the measure of the amount that the data values vary. So basically, how spread out are they? That's another way to think of it. Are they all compacted around the center, or are they spread out quite a bit? So that's an important feature of data as well. Distribution, so the nature or shape of the spread of the data over the range of values is such as bell-shaped, uniform, or skewed. So we're going to see some of those examples later on so you really get a sense of what it looks like. So you can kind of look at it and say, oh, I know what the shape is, and you can kind of get some information based off of that. Outliers are also important. So sample values that lie very far away from the vast majority of other sample values. So if you have data that's all compacted around the center, but then you have a data value that's way higher or way lower, something's weird about that. So a statistician would look at those outliers and analyze whether or not maybe there was a problem with how the data was collected on that particular data value or something along those lines. So those are also going to be important when you're talking about data. And then the last piece is time, changing characteristics of the data over time. So that's a kind of minor piece, but it is important in some instances. So what is a frequency distribution? So we got a frequency distribution, or a frequency table, shows how data are partitioned among several categories or classes. So classes is really how we're going to describe them, by listing the categories along with the number, the frequency of data values in each category. So here's an example. We got pulse rates in beats per minute of males and females. So we got pulse rates from 60 to 69. There was 12 people that fell into that category, and so on. So you can kind of see it's pretty logical in how they set it up. But now, as far as creating a frequency distribution, well, there's some key terms that we got to learn about. So let's go to the next page, see what those are. So now the problem with the notes is that you almost have to flip back and forth between the two pages. So I'm going to try not to do that. So if you have a copy of it, maybe write down the table on a separate sheet of paper. So the first thing we should do is kind of break down those classes, so those intervals. So you got the lower side and then you got the upper side. So looking back, all the lower values, 60, 70, 80, 90, 100, 110, 120. So all the first numbers in those intervals, in those classes. Whereas the upper is the larger side, on the right side of those intervals. So 69, 79, 89, and so on. So that's fairly common knowledge, I guess, or it makes sense, hopefully. So you got the lower side and you got the upper side of each of those classes. Now, what are some calculations that we can do that are important features of it? So the first one is the class width. So let me read through that. So we got the class width is determined by the difference between two consecutive lower class limits or two consecutive upper class limits in a frequency distribution. It is not the difference between the upper and lower limit of the same class. So subtract vertically, not horizontally. So I'm going to flip back just because it's easier to see with this problem. So if we have this frequency distribution, we want to look vertically for the class width. So in this case, how much do you have to add to go from the lower to the lower? And the answer is 10. So if we add 10, that gets us to the next lower. And if we keep adding 10, then we still stay on those lowers. There's nothing weird or mistaken about it. And we could have done that on the other side as well. So the upper to the upper is that same class width of 10. So that's the important piece of this. So 10 should be the class limit, or excuse me, the class width. But a common mistake people make is they want to subtract across. And that's where people make mistakes. You don't subtract across. So a common mistake would be to say this one is 9, not 10. So that's how you would find your class width. So the class width for the previous table is, is 10, not 9. So be careful with that. Always go vertically for class width. So that's the first piece. That's probably the most important piece. The other piece is we can cheat a little bit, because once you know the class width, we're going to be able to cheat to get some of these boundaries, but we do have to get a starting point. So let's read what class boundaries are. So they're the numbers that are used to separate the classes, but without gaps created by the class limits. In order to find them, find the halfway point between the upper limit of one class and the lower limit of the next class. This is the second class boundary. Okay, that seems a little confusing, but let's go through it with the example. So, with an upper class limit of 69 and a lower class limit of 70, this gives us, so we're finding the halfway point. If you're finding the halfway between two numbers, you add them up and divide by 2. So that's all we're doing, is adding those up and dividing by 2. So 69.5 is going to be the second class limit. So let's go back to the table. I know, just so you can see. So let me erase this a little bit. Okay, so we have our table. So they were looking at 69 and 70. The upper limit of one class and the lower limit of the next class. They're trying to find the halfway point between them, because right now, if you had a data value that was 69.3, where does that go? It doesn't go in the first one, and it doesn't go in the second one, so it's in limbo. And that's what these boundaries are trying to do, is trying to take care of those weird instances, if there are any. So 69.5 is the halfway point. So that's kind of the break spot for those two classes. So that's where it comes from. But the problem is that we got to look at what happens before the 60 and what happens after each one of these, all the way up to the 129. So let's take a look and see how we get those. So once you've determined that second class boundary, now we can cheat and use the class width. So we know that class width of 10, so all we got to do is add and subtract from that 69.5, and that's it. And that gets us all the boundaries. So if we subtract 10, we'll get 59.5. If we add 10, and if we add 10, and keep adding 10 until we get to the end of the table. So 109.5, 119.5, 129.5. So remember, the table went all the way up to 129, so once you get a little bit beyond it, you're done. Now, another little check that you can do for these is count how many boundaries you got. Now, if you go back to your table, we had 1, 2, 3, 4, 5, 6, 7. I'm sorry. 1, 2, 3, 4, 5, 6, 7. There's 7 classes, 7 intervals in your table. But let's count how many boundaries we got. 1, 2, 3, 4, 5, 6, 7, 8. And that's always going to be the case. There's always one extra boundary no matter what size table you got, because you're starting a little bit before it starts and you're ending a little bit after it ends. So there's one extra always. So we're going to see some other examples in a second. So if you're a little lost, it's okay. We're going to beat this into your head. So figuratively speaking. All right, class midpoints are the values in the middle of each of the classes. Each midpoint is found by adding the lower class limit to the upper class limit of the same class and dividing the sum by 2. So with a lower class limit of 60 and an upper class limit of 69, this gives us 64.5. So that's the halfway point in that first class. So there it is. Now we can cheat again. We can use the class width, and we keep adding to get the rest. So 74.5 would be the next one, 84.5, 94.5, 104.5, 114.5, 124.5, and that's it. Now let's do our little check of counting. How many do we got? Do we have one extra like we did with the boundaries? 1, 2, 3, 4, 5, 6, 7. So here we get the same number of midpoints as we do classes. So boundaries are a little weird because there's one extra, but midpoints there should be the same number. Now, a lot to absorb there. So we're going to do 2 examples, and then we'll stop the video and finish with some other videos. All right. So far, so good. Take a breath. All right. Let's try this one. So we want to identify the class width, identify the midpoints, identify the boundaries. And again, it doesn't matter what order, but more than likely you want to do the width first. So what would be the class width? I'm going to abbreviate for short, CW. What's the class width for this frequency distribution? So if you're looking at your values, how do we find the class width? Make sure you go vertically or horizontally? Vertically. So you want to see how much do we have to add to go from the lower of one to the lower of the next. So we got to add 9. So 9 should be our class width. Don't think it's 8. It's 9. So add 9, add 9, add 9, add 9, and it should check all the way down. And you can do it on the other side. If you add 9 to 38, that gets you to 47. So 9 is the magic number. All right, that's done. Now, if you want to do midpoints next, you can do midpoints next, but I'd like to do the boundaries next, so I'm going to do the boundaries. So now, the first thing we should probably put down is how many boundaries we should have. So how many boundaries are we going to need for this table? So we got 1, 2, 3, 4, 5, 6 classes. So that means there should be one extra. So there's one extra. So there should be 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we know there should be 7. And now the process works on finding the second one first. So the second one we want to find. So let's just erase this for a minute. And now the process was to look at the end of the first and the start of the second. What's the halfway point between those two numbers? Yeah, 38.5. 38.5. And that's the second one. All right. And now comes the cheating part. Use that 9 to get the rest of them. So if we subtract 9 from that, we get 29.5. Add 9, we get 47.5, 56.5, 65.5, 74.5, and 83.5. Now it's very easy to make a arithmetic mistake with this stuff. So, if you're not doing it on a calculator, you're doing it in your head, that's fine, but just be careful. I like to just double check the last one to make sure it looks right. So 83.5 should be the last one, and it should end a little after the upper limit of the last class. So, and it does. So it's a little bit bigger than that 83, so we're probably good. And also, you can kind of eyeball the rest of them. They should fall into the cracks, remember. So 74.5 is a little after that, a little bit before this. Good. 65.5, a little after this one, a little bit before this one. So we're probably in good shape. All right, now the midpoints. So remember, the midpoints stays in the same class. It takes the upper and the lower of the same class. So now we're averaging across. So we got 30 and 38 is 68 divided by 2, which is 34. So 34, and it kind of looks like it's in the middle, so we're probably fine. But now comes the shortcut. Use that 9. So 43, 52, 61, 70, and 79. So that should be it. That wraps up that problem. So, all right, let's do it again for some new problem. So same stuff. Okay, let's start with the class width. What would be the class width of this frequency distribution? Go vertically. So what's the difference vertically? It's only 1. So 1 is your answer. 1 is the class width. All right, so let's get our class boundaries. How many of them should we have? Yep, you got it. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. All right. So let's get the second boundary first. So again, we're looking at the end of the first, the start of the second. What's the halfway point of that? Those two. Yep. If you use your calculator, you got 0.95. 0.95 should be your your second class boundary. All right, and now we can cheat. Use that 1. So first subtract it. So what happens when you subtract 1 from that second class boundary? What do you get? You get a negative. You get a negative answer. You get negative 0.05. Now wait a minute, that seems weird, right? But look at your table. Your table starts at 0. So if you want to start a little bit before it, you got to go into the negatives. There's no way around it. So a negative class boundary for that first one is okay. It seems weird, but because your table starts at 0, your boundary has to be negative. That first one has to be negative. So, okay, so that is the first one. We got our second one, so now we can add 1 the rest of the way. Add 1, add 1, add 1, add 1. Boom. All right. Let's get our midpoints and we'll call it done. Averaging across. So if we add those up and divide by 2, so 0.9 divided by 2 is 0.45. And now cheat. Add the 1, add the 1, add the 1, and add the 1. It's very quick once you have that class boundary. And you got to do a little bit of math to get the first one or the second one, but then you can just use that class width to just hammer through the rest of them pretty fast. So, all right, let's stop there and we'll pick up the rest hopefully in the next one. See you in a minute.